Dear students, in today's class, we are going to see remaining problems of radiation. I think in last lecture, we have covered the problems up to problem number 20. Now we are going to start with problem number 21. So I will copy it. I will paste here so that we can interpret the data. Now, let's start writing the data. The net radiation from surfaces of two parallel plates. So I will draw two parallel plates. This is epsilon 1 and epsilon 2 are the emissivities. They are maintained at temperature T1 and T2. Maintained at temperature T1 and T2. The net radiation from surfaces of two parallel plates maintained at T1 and T2 is to be reduced by 99%. Of course, heat transfer rate is reduced. That means with the help of radiation shields. So what they have asked, calculate the number of screens. Screens means what here? Screens means shields, radiation shields, to be placed between these two surfaces to achieve the reduction in heat exchange, assuming emissivity of the screens. So let us say how many shields are there? They have not given, and same thing they have asked to us. How many shields are added so that heat transfer rate is reduced by 99%. Okay, so let's say 3, this is 4 dot 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 n number of shields are added between surface 1 and surface 2, and it is asked to calculate how many shields are added so that heat transfer rate is reduced by 99%. Now what is given? Emissivity of the screen as 0.05. They have given emissivity of shield as 0.05. All shields. All shields means how many? N. All N shields. Okay, N number of shields. And that of surfaces. Surfaces means surface 1 and surface 2. Epsilon 1 is 0.8 and epsilon 2 is also 0.8. So, and what is the required answer? Or to find N. N means what? Number of shields. Okay. So by adding number of shields, your heat transfer rate is reduced by 99%. Means let's say Q1 is equal to heat transfer rate without shield, without shield means nothing is there between two surfaces 1 and 2, and Q2 is heat transfer rate with shields, with N shields, N means number of shields. Okay, we don't know that, and that is only we need to calculate. That is a question. So Q2 is given as, it is reduced by how much percent? Reduced by 99% means Q2 is 0.01. Reduced by 99% means only 1% is remaining. So we have to multiply by 1%. 1% means what? 0.01 into Q1. It is not reduced to 99%. अगर reduce to होता तो आप 0.99 से multiply करते. 99% means 0.99. लेकिन it is reduced by 99%. So reduced by 99% means there is only 1% remains. So 1% means 0.01 into Q1. Okay. So it's very important. Reduce by and reduce to. It is reduced by, and that's why only 1% remains. That's why 0.01 से multiply किया है यहाँ. Okay. So this is given thing to you. This is given thing. So first we will calculate Q1 and then we will go for Q2. And there is a relationship now between Q1 and Q2. So what is Q1? Q1 is without shields. Without shields means there is only one and there is only surface 2. Okay, no shields are there. And what is epsilon 1? Epsilon 1 is 0.8, epsilon 2 is 0.8. 0.8, 0.8. Okay, so Q1 is equal to sigma A T1 raised to 4 minus T2 raised to 4 divided by 1 by epsilon 1 plus 1 by epsilon 2 minus 1. Okay, so sigma, I think the no value they have given for temperatures also, so I will keep as it is, sigma A T1 raised to 4 minus T2 raised to 4, numerator as it is because no values mentioned for T1, T2 and A, 1 by epsilon 1, 1 by 0.8 plus 1 by 0.8 minus 1. So if I will calculate the bracket and take a inverse of it, okay, if I will calculate this bracket and take a reciprocal of it, I will get the answer of 0.6666 in bracket sigma A T1 raised to 4 minus T2 raised to 4. Okay, this is your heat transfer rate without shield. Now we will consider the next case where there are number of shields are added in between. Okay, number of shields are added between this. So this is surface 1, this is last surface 2, 3, 4 dot 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 n number of shields are added. Okay, so in that case what is the formula? This is case 2 Q2 with shield. So what is the formula? If number of shields are added and having same emissivity, this is given in the formula list, you check it, sigma A T1 raised to 4 minus T2 raised to 4 divided by 1 by epsilon 1 plus 1 by epsilon 2 minus 1. This is the formula which is radiation heat exchange between two surfaces. Now if there are n shields, so this thing is added because of number of shield, 2 upon epsilon s, okay, 2 upon epsilon s minus n, but here it is twice times n, epsilon s minus n. So this is the formula we need to use to calculate the number of screens or number of shields when all the shields are having equal emissivity. Okay, so this formula is best fit in this problem. Why? Because n number of shields are added and they are having same emissivities and we need to calculate the value of n, so this formula is the best fit. So okay, so let's start with Q2 calculation. Q2 numerator as sigma area and T1 and T2 for both the cases remain same, so I am not substituting the values. 1 by 0.8 plus 1 by 0.8 minus 1, okay, same bracket, plus twice n epsilon s, okay, epsilon s. What is the emissivity of the shield? Emissivity of the shield is given as all the shields, it is 0.05 minus n, okay, minus n. ठीक है. Now we know the relationship between Q1 and Q2. This is the relationship. By adding number of shields, heat transfer rate is reduced by 99%. So multiplied by 0.01. So I will substitute the values of Q1 and Q2 in this expression. So what is Q2? This is the Q2. Sigma A T1 raised to 4 minus T2 raised to 4 upon, what is the value of this bracket? This value of this bracket comes as 1.5 plus twice n upon 0.05 minus n, okay, is equal to 0.01 of Q1 What is Q1? 0.6666 point into 0.6666 in bracket sigma A T1 raised to 4 minus T2 raised to 4. Okay. Now, I think this and this gets cancelled. So what is the remaining thing? Just cross multiply, we'll get the answer. Okay. So this into this, denominator is having only 1, na? So here nothing is there, means 1 into 1 becomes 1. Okay. 1 in bracket 1.5 plus twice n upon 0.05 minus n, okay, into, just 1 minute, 0.6666 into 0.01. So that becomes is equal to 6 point, okay, sorry, multiplied by, this is a cross multiplying, na? So this becomes 6.666 into 10 raised to minus 3. Now this parameter I am taking in multiplication of this, and if we will solve this equation, okay, if we will solve this equation, it becomes 1 is equal to, just 1 minute, it becomes 9.999 into 10 raised to minus 3 plus 0.2666 n minus 6.666 into 10 raised to minus 3 n. So if I am solving it, the value of n becomes 3.80, but 3.80 should not be the number of shades. It has to be rounded into a whole number. Number of shades are either 1, 2, 3, 4. So they are whole number. They can't be partial. So 3.80 I will round up to a nearest whole number, that is 4. So this is number of shades answer. Okay. You can calculate above expression. I have written it directly, but you can calculate it. It comes around 3.80, so equal to 4. Okay. We'll go to the next problem. Problem number 22. Let's copy paste it. Okay. So let's interpret the data for this problem. A cylindrical heater element. Now see, till now we have solved the problems of flat parallel plates with shades, without shades. Now cylinder is coming into picture. A cylindrical heater element with diameter 2 cm has emissivity of 0.7. It is kept at 727 degrees Celsius and it is located in a large room. So there is a cylinder just like this. You can see the pane. So this is a cylinder and this one is a room. Okay. And this cylinder is kept inside the room. So I will try to draw a figure. For example, this is a room. And inside this there is a cylindrical pane, or let's say cylindrical heater element, sorry, because they have mentioned here it is a cylindrical heater element with diameter 2 cm. What is the diameter of that? 2 cm. So what is the value in meter? 0.02 meter. Has emissivity. What is the emissivity of cylindrical surface? 0.7, that is given. What is the temperature of that surface, cylindrical surface? 727 degrees Celsius. So 727 plus 273, it becomes 1000 Kelvin. Convert in Kelvin, that is important for radiation. It is located in a large room. Room is what? Large. So this large word is containing something large. It has some mathematical data hidden in it. Whose walls are maintained at room ki wall, whose walls are maintained at 27 degrees Celsius. So T is 27 degrees Celsius. So it is 300 Kelvin. Now cylinder is inside. So number 1, and room is outside. So number 2. It's very important. The inside should be assumed always 1 and outside should be assumed always 2. When 1 is enveloped or covered by or enclosed by another object. So which one is 1 and which one is 2? It has to be decided. Whatever is inside is 1 and whatever is from outside, that is 2. Because on the basis of that assumption only formulas are derived, and that formulas we are using to do the calculation. So that's very important. Innermost is 1 and outermost is 2 when one body is covering other body. So by that way, this cylinder is having 1000 Kelvin, that is T1, and room is covering, it is outside, so that is T2, and whose temperature is 27 degrees Celsius, means 300 Kelvin. So T1 and T2 is decided. Inside is 1 and outside is 2. Okay. And what is they have asked? Find the rate of radiant heat transfer. So they have asked, required answer is Q1 to 2 per unit length. So cylinder is having the length is equal to, per unit length means L is equal to 1 meter from the heater towards the wall of the room. So heater is 1, cylindrical heater is 1, and towards wall is 2. So Q1 to 2 is asked to you. So we'll go for solution. So you know that we have seen the formula. If one body is enclosing other body, then what is the formula between radiation heat exchange between such case? Q1 to 2 is equal to sigma A1. Now A के जगह A1 आएगा because this case is not of flat parallel planes. It is a case of one body is enclosed by another body. So it is sigma A1 T1 raised to 4 minus T2 raised to 4 divided by 1 by epsilon 1 plus, formula is changed, A1 by A2 1 by epsilon 2 minus 1. This is the new formula. Why new? The reason is this is not a case of flat parallel plate in front of each other. It is a case of one body is enclosed in another body. So we need to use a new formula now. Okay. Now in this formula everything is known except area. So better to calculate area first. So what is A1? It is a cylindrical heater element. Uska area. It is inside body, na? So A1 is area, surface area of inside body, pi d1L. So pi d1. What is the diameter? Cylindrical means pi dl, na, area, or 2 pi r into L. Here diameter is given, so I will use pi dl. 0.02 meter. 0.02 into 1. So A1 comes around 0.0628 meter square. That is A1. A2 is what? Area of large room. Area of large room, but no dimensions given. So you can see in the problem there are no dimensions for the room given. So we can't calculate the area of the room. So keep as it is. Okay. Now, but remember, when we are doing A1 by A2, it is 0.0628 divided by area of large room. Large means it is very, very large. Very, very large. So what I will do, if it is large room, that I will take it as a infinity. So anything very large room, so it is infinite area. It is an assumption, huh? But as the data is not given, we have to consider this assumption. So that's why I told this large has certain meaning when the dimensions are not given. Large means what? Infinite. So area is also coming infinite. So anything upon infinity becomes 0. So A1 by A2 ratio comes 0 in this case because of large room. So just put the values. Q1 to 2 is equal to sigma 5.67 into 10 raised to minus 8. A1, what is A1? 0.0628 into T1 raised to 4. What is T1? 1000 minus 300 raised to 4 divided by 1 by epsilon 1. What is epsilon of cylinder? सिलेंडर का एमिसिविटी दिया हुआ है, that is epsilon 1 0.7, 1 by 0.7, but the value of this A1 by A2 is 0. A1 by A2 is 0, so anything multiplied by 0 is 0, so I will write it as 0. If I will solve this equation, I will get the answer of Q1 to 2 is 2472.34 watt. So this is the answer, okay, for this problem. Radiation heat exchange between cylindrical heating element to the wall, but wall is what? A very large wall. Dimensions are not given and they mention the wall is large. Okay. Now we'll go to the next problem. That is problem number 23. Let's copy paste this PPT. Start writing the data. A cryogenic fluid flows through a tube of 30 mm diameter, which is concentric with a tube of 90 mm diameter. So there are two tubes. Concentric means one is covered by other and center is same. So you know which formula we need to use. Just like last formula. One body is enclosed in other body. One tube is covered by other tube. So surface emissivities of inner and outer tubes are 0.2 and 0.5. So innermost is numbered as 1 and outermost is numbered as 2. Epsilon 1 is given as 0.2. Outer tube is 0.5. So epsilon 2 is 0.5. Okay. D1 is 30 mm. D1 is 30 mm. 30 mm means how much meter? 0.03 meter. And D2 is 90 mm. So 90 mm means 0.09 meter. Okay. Their temperatures are 100 Kelvin and 300 Kelvin. So inner temperature is 100 Kelvin. Already it is in Kelvin. So no need to add 273. And T2 is 300 Kelvin. Okay. Respectively. Respectively means inner and outer. No? Inner and outer. So T1 is 100. T1 is 100, inner and 100, outer and 300 respectively. Find the heat gain rate. Find the heat gain rate. If the radiation shield of 45 mm, so there is a shield between two surfaces. This dotted is a radiation shield. So I will number it as 3. 1, 2 and 3, just like flat parallel plates. Numbering is like this. Of 45 mm diameter. So D3 is how much? D3 is diameter of shield, 45 mm. 45 mm, that means 0.045 meter. Having emissivity. What is the emissivity? That is epsilon 3 is 0.1. On inner surface means this shield is having emissivity different from both surfaces. On inner surface it is different and on outer surface it is different. So epsilon 3 towards 1, that is inside. Epsilon 3 1 is 0.1 and towards outside means towards 2. So epsilon 3 towards surface 2 is 0.05. So here radiation shield is having, let's say this is a shield. This shield is having emissivity different at this surface and different at this surface. Till now, all radiation shields, we have seen the problems, different problems. In all radiation shields, on both sides, the emissivity is same. But in this problem, shield is having two different emissivities on two different surfaces. Towards one, it has emissivity of 0.1, and towards 2, it has emissivity, towards 2 means outer surface, it has emissivity of 0.05. So this is important point to note. Okay. And what they have asked, which shield, what is the heat gain rate? So required answer is, or to find, Q1 to 2. Okay. So we'll go for the solution. So in case of one body enclosed by another body, or they may be concentric tubes, or they may be concentric spheres. In that case, what is the formula used? Q1 to 2 is equal to sigma A1 T1 raised to 4 minus T2 raised to 4 divided by 1 by epsilon 1 plus A1 by A2 1 by epsilon 2 minus 1. Okay. This is the formula for without shade. Plus, in the problem, one shade is there already. One shade is there, that is number 3. So for this, I need to write one more term. A1 by A3. A1 by A3. 2 by epsilon 3, that is this term you are writing for a shield, na? So 2 by epsilon 3 minus 1. But remember, this formula I can't use. There is a reason for it. This formula is under the assumption that shield, that is surface 3, is having same emissivity on the both sides. But in our problem, emissivity different on different side for the shield. So our formula get modified as one by epsilon 1 plus A1 by A2 1 by epsilon 2 minus 1 plus A1 by A3. 3 means shield. This term is because of shield. Now, as the shield is having different emissivity on two different surfaces, this 2 by epsilon 3 you have to write like that. You have to split that into two surfaces. 1 by epsilon 3 towards 1 plus 1 by epsilon 3 towards 2. Shield is having different emissivity towards surface 1 and shield is having different emissivity towards surface 2. So that's why we have done the splitting of this particular term. Okay, minus 1 as it is. So let's start. Substitute. Sigma is 5.67 into 10 raised to minus 8. Okay. Important thing is I have written it directly, but before going to this, I need to know the values of areas. Okay, let's calculate all areas. How many areas are involved? A1, inner tube, A2, outermost tube, and A3. A3 means shield inserted. Okay, so let's start. A1. A1 is what? 5 D1L. 5. What is D1? D1 is 0.03, and whether the length is given in the problem. Okay, the length of the shield is not given, so by assuming it as 1, 5 D1, D1 is 0.03, 0.03 into 1. Okay, assume L is equal to unit length, L is equal to 1 meter. So what is the answer of A1? A1 is equal to, just 1 minute. A1 is equal to, I have done already calculation for you, 0.0942 meter square. Similarly, we will go for A2. A2 is outermost tube, pi D2L. Pi D2 is how much? 90 mm means 0.09 meter. 0.09 into length is assumed as 1, so its answer is 0.2827 meter square. Now finally A3. A3 is equal to pi. This is for shield. 3 means shield inserted between surface 1 and surface 2. Pi d3l. Pi. What is the diameter? 0.045 into 1. That becomes 0.1413 meter square. Okay. Now we'll calculate A1 by A2. What is A1 by A2? A1 by A2 is equal to, A1 is 0.0942 divided by A2 is 0.2827. This comes around 0.3332. Okay. And A1 by A3 we will calculate. Why? Because see here, there is a term called as A1 by A2 here, and there is a term called as A1 by A3 here in the formula. So better to calculate it separately so that it will be easy on calculator then. A1 by A3. So what is A1? 0.0942. What is A3? 0.1413. So it comes around, I have done it, 0.6666. Okay. Now let's go for substitution then now. So let's Q1 to 2. Q1 to 2 is equal to sigma 5.67 into 10 raised to minus 8. A1 0.0942. Just take the value. See A1. A1 is how much? 0.0942 into T1 100 raised to 4 minus 300 raised to 4. Inner tube temperature. Inner is 1 na? So 1 is T1 100 raised to 4 and outermost is 300. So T2 is 300 divided by, okay, let's start. 1 by epsilon 1. What is epsilon 1? 0.2 plus A1 by A2. A1 by A2, this term already calculated, 0.3332. 0.3332. 1 by epsilon 2. Epsilon 2 is 0.5. Okay, minus 1 plus A1 by A3. This term, this term. How much it is? 0.4 times 6. 0.4 times 6. Okay. And then this splitted term, 1 by epsilon 3 towards 1. 1 by 0.1 plus 1 by epsilon 3 towards outside surface 2. That is 0.05 minus 1. Okay. And if I will do it, numerator, I will calculate numerator separately. It comes around minus 42.72 and denominator comes as this 1 by 0.2. If I will calculate, it comes at 5. Then this second term, if I will calculate this one, this comes at 0.3332, and if I will calculate this third term, that comes around plus 19.33. So why I am doing it separately, the reason is there may be a mistake on the calculator when you are trying to solve a bigger expression in a single step. So better to do it separately. Add this and you will get minus 42.72 divided by 24.66. So it comes around minus 1.7323 watt, and it is per meter na, because length is assumed as 1 meter. So better to write it as, rather than simply watt per meter. If it is per unit area, we are writing watt per meter square. If it is per unit length, we are writing watt per meter, because length is assumed as 1 meter. So this is your answer, Q1 to 2. But what is the meaning of minus sign? Negative sign indicates that heat transfer is from outside tube to inside tube, because the formula is derived Q1 to 2. 1 to 2 means 1 is innermost and 2 is outermost. So formula is Q1 to 2 means from inner to outer. And what is the answer? Answer is negative. So that means heat transfer is not from inner to outer. It is from outer to inner. So that's why it is written here significance of negative sign as negative sign indicates heat transfer is from outside to inside rather from inside to outside. So this is very important. Significance of negative sign carries half mark. Okay, so you have to write. Now we'll go to the next problem. I think we covered 23rd problem. Now we'll go to the 24th. Let's go to the PPT. I will copy paste it here. Let's interpret the data. Low temperature cryogenic fluid is stored in a sphere of diameter 30 mm, which is concentric with outer sphere. So this is a case of one sphere enclosed in another sphere. So you know the formula for one body is enclosed in another body. So innermost is 1, outermost is 2. What is the innermost diameter? D1 is 30 mm. 30 mm. 30 mm means 0.03 meter. Outermost D2 is 90 mm. 90 mm means 0.09 meter. Okay, convert into meter. Surface emissivity of inner means 1. Epsilon 1 is 0.2. Outer epsilon 2 is 0.5. Okay, 0.5. And their temperatures are, inner is T1 is 100 Kelvin, already in Kelvin, and T2 is 300 Kelvin. Okay. Find heat gain rate by the cryogenic fluid. So what is asked to you? A required answer is ask Q1 to 2. Okay. Now we'll go for the solution. Now, what is the formula? Just recall the formula. One body is enclosed by another body. Here, one sphere is enclosed by another sphere. Means one is inside sphere and other is outside sphere. So this is the case of one object is covered or enclosed by another object. Innermost is numbered as 1 and outermost is numbered as 2. Okay. So in that case, what is the formula for Q1 to 2? Q1 to 2 is equal to sigma A1 T1 raised to 4 minus T2 raised to 4 divided by 1 by epsilon 1 plus A1 by A2 1 by epsilon 2 minus 1. Okay. So this is without shade. अगर शेड है तो इसके आगे प्लस और एक टर्म आएगी जो कि उस शेड की होगी. अगर दो शेड है तो दो टर्म और बढ़ेंगे. So there is no shade. So the basic formula is like this. So what is unknown in this formula? Unknown is area calculations. So let's do it. A1 is, it's a sphere, na? So what is the sphere? Inner sphere area 4 pi r1 square. And what is A2? 4 pi r2 square. So 4 pi r1. We know D1, na? So what is R1? R1 is 0.03 divided by 2. Yes, I am doing it. 0.03 divided by 2. It is 0.015. 0.015 meter. And what is R2? 0.09 divided by 2. It is 0.045. 0.045 meter. So I know R1 and R2. Because formulas are in terms of R1 and R2, na? So we need to go for radius calculation from diameter. Just divide by 2. So R1 and R2 I know. 4 pi R1 square. R1 is 0.015 square. And R4 pi R2 0.045 square. So the answers of A1 and A2 are, yes, just a minute. A1 is coming as 2.8274 into 10 raised to minus 3 meter square, and A2 is coming as 0.02544 0.02544 meter square. So A1 and A2 is known to you. Let's do it. A1 by A2 term is present in the formula. So calculate it. A1 by A2 is equal to 2.8274 into 10 raised to minus 3 divided by 0.02544. If I will calculate A1 by A2, it comes around 0.1111. Okay, let's do it now. Just do the substitution. Sigma 5.67 into 10 raised to minus 8. A1, I am going to put the value of A1. What is A1? 2.8274 into 10 raised to minus 3 into T1 raised to 4 minus T2 raised to 4. T1 is 100 and T2 is 300. So 100 raised to 4 minus, this should be in Kelvin. Already values are in Kelvin for this problem. Divide by 1 by epsilon 1, 1 by 0.2. Epsilon 1 is 0.2. So 1 by 0.2 plus A1 by A2 value, this value, A1 by A2. It is 0.1111. 1 by epsilon 2. Epsilon 2 is 0.5 minus 1. Okay. If I will calculate only numerator, it comes as minus 1.2825. And then denominator, this particular term is coming as 5 plus this term. If I will calculate on calculator, it comes at 0.1111. Okay, and the final answer is coming as minus 0.2509 watt. Okay, watt. Again, negative sign indicate that. Tell me, students, negative sign indicate that heat transfer rate is, because the formula is derived on the basis of 1 to 2. 1 is inner and 2 is outer. So we are assuming heat transfer is radially outward, but answer is negative. Answer is negative means our assumption is not correct. So negative sign indicate that heat transfer is from outside sphere. This case is sphere, no? So outside sphere to inner sphere. Inner sphere. See, our formula is based on the basis of 1 is inside and 2 is outside. So we are assuming heat transfer rate is radially outward. So we are getting the answer of Q1 to 2 is negative in this case. So that means heat transfer rate in our case is what? Not like this, not radially outward, it is radially inward. That means from sphere 2 to sphere 1, that is outside sphere to inside sphere. So this is the correct direction. This is, your assumption is wrong. So you need to write only significant, that's it. Okay, we'll move to the next problem now. And this is the last problem, I think. Yeah, for the radiation. So I'm copy pasting it in PPT. Yeah, I'm making it bigger for you. Now just interpret the data, please. Okay, dimensions of the room are 10 by 10 by 7 meter height. So I will draw a room. Room has 6 faces, na? Roof, floor and 4 walls. Okay, so this one is what? Roof. This is roof. And what are the dimension? 10 meter by 10 meter. So this is 10. This is 10 meter, 10 meter. And they specially mention 7 meter height. So this dimension must be compulsorily 7 meter. So this is your height. You can't put 7 meter here and here. This is very important to understand. They mention it is a height. 7 meter आप सिर्फ height vertical ही ले सकते हो. हॉरिजॉन्टल नहीं ले सकते, दैट इज वेरी इंपॉर्टेंट टू अंडरस्टैंड. The roof temperature is 60 degree Celsius. So T of roof 60 डिग्री सेल्सियस. मान लो कि ये रूम है, मैं जहां बैठा हूं या आप जहां बैठे हो, उसका जो रूफ है ऊपर का, उसका टेम्परेचर है 60 डिग्री सेल्सियस. आई विल कन्वर्ट इन केल्विन इमीडिएटली. तो 60 plus 273, it comes around 333. 333 Kelvin. Okay, Celsius is not allowed in radiation because of that Stefan-Boltzmann law. While walls and floors, so T of walls and floors is equal to 30 degree Celsius. So 30 means I think it is 303 Kelvin. Okay. Calculate the rate of heat transfer from the roof to the wall. So of course, so आपको roof to the walls. So I will go for number 1 as roof, and number 2 I will take it as walls plus floors combiningly. Why? Because in the problem the temperature of wall and floor are not different. There are 4 walls, side walls, and 1 floor at the bottom, but they have given temperature of all 4 walls and the floor same, that is how much? 30 degree Celsius. So instead of treating them as a separate body, I will treat 4 walls and floor as a single body, because they have assigned a single temperature to that walls and floor combiningly. So I will call 1 as a roof and 2 is walls plus floor, because that roof is enclosed from all sides by 4 walls and as well as floors. It is covered. Okay, so this is again a case of 1 is enclosed by 2. Okay, because all walls and floors are radiating heat towards roof, so it is a case of 1 and 2. So we can use the same formula what we have used earlier. Now they have given something extra, emissivity of walls and floor. So आपने walls and floor को 2 माना है, so epsilon 2 is equal to, epsilon 2 means what? Walls and floors, क्योंकि 2 को आपने walls and floor बोला है, that is 0.8, and epsilon 1 that is roof is 0.6. okay, 0.6. तो ये रूफ जो है, ये जो रूफ है इसको मैं नंबर 1 देता हूं, और बाकी ये जो 4 वॉल है साइड के और नीचे का जो फ्लोर है, ये वाला फ्लोर है ना, ये फ्लोर को मैं, और 4 वॉल का जो इमिसिविटी है उसको 0.8 बोला है मैंने. ठीक है, नंबर 2 बोला है, एंड उसकी इमिसिविटी है 0.8. सो हाउ टू सॉल्व द प्रॉब्लम? You know, if one body is enclosed in another body, then Q1 to 2 is equal to sigma A1 T1 raised to 4 minus T2 raised to 4 divided by 1 by 1 plus A1 by A2 1 by epsilon 2 minus 1. This is the fundamental formula without any shades. Okay, if the shade is there, then one extra bracket is added. 2 shades are there, 2 brackets are added, but here there is no shade. Okay, between that roof, walls and floor. So let's do the calculation for A1 and A2. So A1 is equal to, what is A1? आपने 1 किसको माना है? रूफ को. So A of roof. What are the dimensions of the roof? I think it is, ये 10 मीटर होगा और ये भी 10 मीटर होगा, तो 10 by 10, 10 into 10, it is 100 meters square. Okay, A2 means what? Combiningly 4 walls plus floor. एक फ्लोर है और 4 साइड के वॉल है, और इनको मैंने एक ही ऑब्जेक्ट क्यों माना, एक ही बॉडी 2 क्यों नाम दिया? उसका एक कारण है कि उसका टेम्परेचर एक ही दिया है, अलग अलग नहीं दिया. सो एरिया ऑफ 4 वॉल, तो 4 वॉल 4 इंटू 4 वॉल है इसीलिए 4 इंटू, एंड हाइट कितनी है इसकी, एक वॉल का ही लेता हूं, ये 7 है हाइट, 7 मीटर. सो 10 by 7 इंटू 4 इंटू 10 इंटू 7. ओके, ये हुआ क्या? वॉल. ये क्या हुआ? वॉल्स. 4 वॉल्स का एरिया हुआ, प्लस फ्लोर, एक ही फ्लोर है बॉटम की, उसका एरिया क्या होगा 10 by 10, जो रूफ का है वही फ्लोर का एरिया होगा. सो 10 by 10, 10 by 10, this is floor area. Okay, this is floor area, and if I will solve this, the answer of A2 comes as, just 1 minute, I have done it. It comes at 380 meter square. So in the formula there is term called as A1 by A2, so I will calculate it separately. A1 by A2 is 100 divided by 380. If I will do it, it comes at 0.2631. okay, no unit for this because it's a area ratio. ठीक है. Now I will go for substitution. Q1 to 2 is equal to 5.67 into 10 raised to minus 8. This is sigma. Look at here. Then A1. What is A1? A1 is 100 meter square. 100 into T1 raised to 4. What is T1? 1 आपने रूफ को बोला है तो 333 raised to 4 minus, then wall and floor को आपने 2 बोला है तो that is 303 raised to 4. केल्विन में करो, ऑलरेडी मैंने केल्विन में करके रखा है. डिवाइड बाय 1 by epsilon 1. 1 is roof, तो what is epsilon 1? 0.6 प्लस A1 by A2 की वैल्यू 0.2631. what is walls and floor की एमिसिविटी कितनी है 0.8 minus 1. okay, if I will solve this, separate numerator and denominator. Numerator is coming as 21928.99 divided by denominator, this first term 1 by 0.6. if I will calculate, it comes at 1.6666 plus, if I will calculate this second term, this term, that answer is coming as 0.0657. if I will solve this, the answer comes as 12658.65 watt. So this is the heat transfer rate from the roof to the 4 walls and floor combinedly. तो रूफ है बॉडी 1 एंड 4 वॉल और फ्लोर कंबाइन करके हमने 2 बोला है. क्यों? क्योंकि उसका एक ही टेम्परेचर दिया है उन्होंने, अलग अलग नहीं दिया, तो इसी को एक ही बॉडी बोलेंगे हम, तो दैट इज बॉडी 2. सो हीट ट्रांसफर फ्रॉम रूफ टू 4 walls and floor is 12,658.65 watt. So that is your answer. And students, with this we are stopping here. I think around in first lecture of radiation problem we have solved 5 problems, and in second lecture we have solved 5. So in totality we solved total 10 problems of radiation. So in the examination you will not find any of the different types from this type of problems, because almost all the variety of the problems I have covered in these 2 classes. So if you solve these 10 problems in the examination, you are in a position to solve any type of problem, because variety is totally covered, means all variety of the problems from radiations are covered. So if the problem comes, they will change the values. okay, so that will be easier for you if you study these 10 problems thoroughly. If you try to solve on your own, don't read the problems, please try to do the calculations on the calculators. Otherwise, you know the procedure, you put the values, all the values properly, but at the time when you are doing the calculations on a calculator, then definitely any one bracket is missed, raised to 4, or what you can say, while taking a 4th root you may find some problems. okay, so that is very very important to do the calculation with the help of your own calculator. That will give you enough practice to solve the problem and arrive at a right answer. That is important. okay, thank you.